Okay, we're going to talk really quickly about tsunami notes. And like I said, this is quick. So let's talk about what is a tsunami. It's basically a big movement of water. And when that happens, it's one of two ways. In the middle of the ocean, on the floor, you can have a fault line. And if that fault cracks and shifts up, that upward motion displaces all the water above it, causing waves to radiate out for miles wide on each side. And it can travel really fast, like as fast as a jet plane. So as it continues to travel, as it gets closer to shore, the wave gets pushed up because the floor shallows. So in deep ocean, you're not even really going to notice it because it's not bottoming out anywhere. It's just a wave that moves all the way through. But as it approaches land and the bottom becomes shallower and shallower, the wave gets pushed up and it starts to slow down from friction. But all the water coming in behind it's still traveling at the same rate. And because of that, it starts to pile up behind it, becoming higher and higher. And here we go. It's coming in shallower and shallower, and it's going to get higher and higher until eventually it just surges in. And this is a never ending stream of water that just keeps coming and coming and coming, which is why tsunamis are so dangerous. The other thing that can trigger a tsunami is a landslide. Massive amounts of material all of a sudden displacing the water and causing it to radiate out. And here comes the tsunami. And it just keeps coming. And it can move quite far inland. This is one you can watch on your own if you wish. Down here, this is an actual recording of a tsunami. This is not a good place to be because tsunamis don't care if there's a wall there. If the tsunami is taller than the wall, guess where the water is going to go? And it's coming in and in and in. And it just keeps rushing forward. Now, a really good indicator that a tsunami could be coming is actually something called pullback. The water will actually pull back and you'll have a really low tide and people are like, cool, let's go look at this. The problem is that's a really good indicator that you should not be there. And that person should really not be there either. So again, don't underestimate the power of water. This is a really quick review. It's basically a section summary. I just took a little bit of it, and we're talking about liquefaction, aftershocks. So severe shaking produced by seismic waves can damage or destroy buildings and bridges, topple utility poles, and fracture gas and water mains. Earthquakes can also trigger landslides, avalanches, and huge water waves. Seismic waves transmit their energy from solid rock to loose rock, which shakes violently. Structures built on solid rock shake less than structures built on loose soil. Liquefaction then occurs when an earthquake violent shaking turns loose, soft soil into liquid mud. As the ground gives way, the structure collapses and landslides may occur. Structures that have been weakened by an earthquake may collapse during an aftershock, which is a smaller earthquake that occurs after larger earthquakes in the same area. An earthquake on the ocean floor causes the floor to rise up slightly and push water out of its way. This creates a large wave called a tsunami. The tsunami spreads out from the earthquake's epicenter and rushes across the ocean. When it reaches shallow water near land, the tsunami's height increases. Sometimes a huge wall of water will hit the land. Answer those couple questions, hit submit. Let me know if you need any help.